Right, so here we are with the next of the box sets, Rotel RVC220. I know we did that one pretty recently for a different customer. Once again, this is presented upside down in the box. Microphones in there, we'll come back to that. Put that on one side. Right, we'll get this connected up to power, see what it does. We'll get this connected, I'll switch it on, get our standard replacement mic connected, and then into the test equipment. Oh, a wire off our test thing. Right, so we'll put the test gear into picture-in-picture, not the test gear, the video equipment. We're on the low range, which is 3 watts on the test set, and it looks like we're on low power. That's better, 2.9 watts. Channel 40. 2.8 watts, channel 1, 2.9 watts, back to channel 20, and on transmit we've got 955 milliamps, and on low power the radio is doing 110 milliwatts. And there we go. Right, so let's have a quick look at the deviation for what it's worth. Wow, this is about 1.5 on this test set. Check that later on the other one. Do the VCO. Let's look at frequency. $27,79077. That needs bringing up. So with that in mind, we will set the signal generator. It's currently on frequency. We'll take it off frequency so that we get a fair test for sensitivity. That's as low as we're going to go without messing, so that'll do. Let's go over to the SINAD meter, which is moved for some reason. This looks like another cracking set. 0.25. Not 0.21 for 20. 0.67. See where we are with the squelch. Let's put that to full. And I want it to open at 100 microvolts, so I'm going to put attenuator up on the inset picture. We're at 1 microvolt, that's 3, 10, 30, it's coming in at 30. Fine tuning that, it's actually 23 microvolts, so that's far too weak. Let's look at sensitivity of squelch. So park the signal generator at 0.3 of a microvolt, set the squelch on the register threshold, signal generator back on, and it is 0.54. We'll put S9 on the signal generator by putting 100 microvolts on, and it says 8, so to get 9 we need 300 microvolts. So that's a lazy, whoops, 300 microvolts there. Let's go back to transmit test. When we key up, what do we get? It says about 3.2, which is about where it is. Meter lamp works, switches work, pots work. Sockets work, doesn't have that. We'll get it taken apart. So it should just be a retuning test. No sleeving on those, how come? Still smells of new radio despite being 40 odd years old. Right, we'll better start with the VCO. Radio back on. Channel 40. Just want to put my test prod to negative instead of the metal chassis, which isn't earth on these. Resistor 4, far end, should be 4 volts, and it's as near as damn it. Yeah, it's like that. Transmit 3.5. I'll just give that a little adjustment with the red trimmer. .03 on transmit, 4.1 on receive. That's done, so we don't want channels dropping off. We'll just check on channel 1 that it's where it should be. 2.3 on receive, 2.3 on transmit. Right, we'll put the meter away. Let's go through the transmitter, select channel 20, so we're in the centre of the band. And we're going to go over to the main meter. We're on the 3 watt scale until such time as we go over the 3 watts. I now think we're at the 3 watts. So we're definitely at 3 watts now. Let's go to the 30 watt scale and get the yellow. This is the yellow tool, but it's actually blue, of course. So I've said this many times. We've done so many Cybernet 134s. You have to peak the 3 coils here, and it's supposed to do more than 4.4 watts in order to balance it. So at 3.5 at the moment. This doesn't look messed with at all. So it's not quite doing 4. What we're going to do, I'm going to up the voltage of the power supply to 14.4 volts just so I can balance this. Don't do this at home. Which button do I press? That one. Right. So let's do that again. We're now at 4.2 watts. Turn off a second, make sure that transistor's tight. So I can't get it to a 4.2. What we're going to now do is we're going to go clockwise with this until it starts moving. Which is there, anti-clockwise with this till we get just above 4, we're about 4.05. Now I'm going to drop the voltage to 13.8 where it should be. Let's see where we are. 3.8. Right, on channel 40 it is 3.7, 3.8. Right, let's go over to low power and see if we can set that up for 100 milliwatts, making sure I'm on channel 20, and that's still 50 milliwatts. So I'll just put some service switch cleaner on that because they do get dry. It's nice and smooth, it doesn't need replacing because it can, if they've been used a lot, the preset can crack up. And let's go back to full power, and now it's cooled down a bit. It's doing a good 4 watts. So when he does the on-the-air test, I'm going to be saying 3.9 watts. That was when it was warm. It does do 4 watts from when cold. Right, where were we? Meter. So that now bangs across to 4.5. So I'll get that set. Remember, this is into a dummy load. It only reads 4 when it's into a dummy load. If it's on an aerial, it may read 1, it may read bang across. It means absolutely nothing. The radio is still doing the same power because it's relative to SWR. Now I want the deviation AGC one to be in the sensor position. I'm not quite sure why they put a preset in, because the European version of this they didn't. But there you go. Right, we'll go to deviation. So I'll use the test set behind me on the Quartz Lock 282A test set. Let's have a look at what it says on there. Wow, it says 2.2. Just pop that up a little bit. Go back to the Marconi test set. See whether it's reading the same. Oh, whether it's lying today. Voila, it's like, oh, I'm on 25 range. Voila, spot on today. It's reading just the same. So it was actually 1.8 kilohertz and it's now 2.2 to 2.5. Let's get it on frequency. Switch over to the frequency counter and 27.79125. Where's the crystal trimmer? Always try and leave them high because they've got latitude then to drop. Right, we'll reset this signal generator to be 27.79125. Now the radio's on frequency. And we'll go over to the SINAD meter. No, we won't. We'll do the oscilloscope. So with S9, 100 microvolt signal on the signal generator, we want to adjust the detector, the FM detector, coil for maximum recovered audio. Already spot on. So if it's wrong one way, recovered audio is quiet. If it's wrong the other way, it's garbled. Let's look at the receive. So it was already really good. Let's go to the SINAD meter. The SINAD meter that's gone for a little walk. Just put about 5 dB on there. So we're not saturating the receiver with the signal. Let's see if we can make any improvement. Not half. Drop the signal a bit. Little tiny bit on that one. That was already spot on. I'm going to put a bit more signal on, do the IF. That was already spot on. Tiny little twiddle on that. Let's get a new reading. .21 microvolts. A little less than 0.2, but we're between ranges then. .45. Good. It's 100 microvolts now on the signal generator. So put that to 0, put that to 100. See what the meter says now. Still doesn't say S9. So we'll adjust it so that it does. I'm not a meter lover. I'd rather have sets which don't. I'm from a business radio background. Yeah, I get this with ham radio. You're 5 and 9, old bean. Well, actually, you're radio 3 and S7. So are you. You know. Oh dear, come on. Can't be inferior. No. That just leaves us with squelch. So we'll put the squelch to full. Still opening too early. So the squelch preset is there. And now it opens at 100 microvolts, which is what I want. So dropping it to minimum, set threshold, the signal generator on standby, signal generator back on, 0.74. Just check transmit once again. Yeah. We'll leave those figures as they are. So, oh, transmit current, channel 20, 1.287. Put it together. Right, switch the test gear off, unplug the test equipment and plug the aerial in instead, which I'll keep saying is an Antron 99 or equivalent, just mounted above gutter level on a single story building. Well, I know Roger. No, nobody out there. Right, there we go. Really immaculate Rotel RVC220 from 1981 using the Cybernet 134 chassis. And thank you for watching.